Good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So, guys, I feel everybody is aware of that today we are starting the practice course for ISRO, and where we will be going with all the subjects one by one and we will discuss the questions on them. Please tell me, am I properly audible and visible to all of you or not? Yes. Fine. Yes. So guys, we are starting the session and today's subject is strength of material. So guys, today we will see 24 questions of strength of material. And guys, as this series is specifically for ISRO paper, so that's why the level of question will be same as that of ISRO PYQs which were there. Okay, so we are starting the session now. Please tell me, am I properly audible and visible? Yes, Arun, good morning, dear. So guys, today's subject is strength of material. This is some detail about me, those who are watching me for the first time. Yes, I'm fine, Arun. So happy to see you here. So guys, on 13th of June, means tomorrow, you have a workshop by Abhinav Negi sir at 7:30 p.m. related to 7 key factors that transform every student to a gate topper. So sir will tell you about that. Yes. So this will be a session if you have already given gate 23 and you are looking for MTech admission. Yes, Lakshmi. So for that, I will be telling you the best sequence of choice filling for mechanical. This session will be there in the video section by tomorrow. Okay. Moving further, this is my Telegram channel, Mechanical by Dheeraj Sardana. You will get the PDF of this and ISRO PYQs and GATE PYQs, everything, handwritten notes onto this Telegram channel. So now, without wasting the time, we are starting with the first question. Okay? Yes. So guys, this is the first question. Natural frequency of mass m on the free end of a cantilever beam of negligible mass, length L, flexural rigidity EI. These are the options. I will give you a hint here because it is one step ahead strength of material. When we are talking about natural frequency, it is given by G divided by delta. Here delta is nothing but the static deflection. It is nothing but the static deflection. What is static deflection? Like, you know, this beam will be deflected. So whatever you are finding out this deflection or why, that you need to keep here and you will get the answer. So just solve this question. Yes, Wahid, good morning, dear. How are you? So just solve it, guys. Arun, Lakshmi, Wahid, all others. Okay, Rakesh is also there with us. Rakesh is saying option C will be the answer. Okay, what about others? According to Rakesh, answer is C. So guys, do like and share the session because this series is specially planned for all the ISRO aspirants so that you can crack the ISRO with very good rank. Because this time 50% weightage is going to be there for written examination. It means if you are going to do good in written, chances of selection are more. VK Verma, it is equally beneficial for civil. Because for mechanical and civil, if you see ISRO paper, the level is almost same only. Okay. Even for ISRO, you will find mechanical level is slightly better than civil. Okay. So it means you will get some benefit, not loss. Okay. Fine. So when you will be solving this static deflection, you already know that for this case, you can find out using this case. If we have a beam, load P is applied. Because of this, you can find out the deflection. The deflection is nothing but PL cube upon 3 EI. So here P is nothing but the weight. So it is mg L cube upon 3 EI. And when you are going to put this value, my dear, as it is into this, you will be getting 3 EI upon ml cube. Yes. Okay, Arun. So answer will be C for this. So Rakesh have given the right answer. Okay. Moving further. Great, Arun. Koi baat nahi. We have done only one question. This is the second question, guys. Okay. So we are going to solve 24 questions in that way. 24 questions. Try to solve this. A thin cylindrical pressure vessel with mean diameter 10 meter. So you are having mean diameter as 10 meters and thickness as 20 mm is subjected to an internal fluid pressure 0.4 MPa. They are saying yield strength of the material SYT to be 200 MPa. They are asking the factor of safety according to maximum shear stress theory. So don't worry, those who do not know the theory of failure, for them I am giving you an idea. First of all, in thin cylinder you are having the state of stress like this. This is sigma C and this is sigma L. You know that in thin cylinder when we are talking about this state of stress, sigma C and sigma L, please tell me both are positive or not, both are tensile or not. Means you know sigma C is PR by T or PD by 2T. You know sigma longitudinal is PR by 2T or PD by 4T. You know that, okay? So when both are positive and there is no shear acting here, so you can directly call it as principal stress 1, it is principal stress 2. When both the principal stresses are of same nature, what do you mean by that? Yes, Anubhav, good morning dear, how are you? So when we are saying both are of tensile nature, it means this is tensile, both are same nature. So when both are having same nature, then maximum shear stress theory is giving the same result as that of maximum principal stress theory. That is the theory given by Rankine, which says nothing but either sigma 1 or sigma 2, whatever is the maximum value, should be less than equals to SYT by N. So my dear, this is the result you will be using. Now tell me the answer. Great, Page Albert, good morning. Please try to solve it, guys. This series is specifically for ISRO and you won't believe, yesterday I told you the entire plan. First we will go with subject wise 24 questions every subject. After that we will be coming up with the formula revision, and every Saturday one previous year's paper is getting sold for you. And when formula revision will be done subject wise, after that we will coming up with the mock test as per the new pattern, because PYQs are as per the previous pattern. So when mock test we will be coming up, there we will use the new pattern, and in between on Sundays we will plan the aptitude classes. Okay, so we have made a complete plan which was previously proposed for the paid course. The same is given to you in the free on YouTube from BYJU'S Exam Prep. Yes, Pajal have given the answer to be C. What about others? So this is PR by T, we will use PR by T. So PR by T less than equals to SYT by N. So you can see the pressure is 0.4 MPa. You will put the value 0.4. Radius is going to be 1 by 2 of diameter. It will be 5 meter. So 5 divided by thickness is 20 mm. So you can write it is less than equals to what is SYT? SYT is 200 divided by N. Tell me what will be the answer. Abhijit is saying the answer to be D. Pejal is saying the answer to be C. I feel I can clearly see that if I will cancel it by 4 and cancel it by 0.1, then answer will be looking like 2. Is it clear? Lakshmi, very good. So answer will be 2, not 1.5. Pejal, you have done some mistake. Arun, got it or not? Anubhav, got it or not? Please tell me that, guys. Any doubt, please ask me. I will help you out. Okay, this is the only question from theory of failure. All other questions are from other topics. So civil people, no need to worry. Moving further. This question, my dear, is very easy, and this is given as 100 Newton meter. So for the beam loaded as shown in the figure, the magnitude of the bending moment at the roller support. You will see this type of question many times ISRO and DRDO have asked. Many times ISRO and DRDO have asked. If you see the level of DRDO objective, ISRO objective, they are almost same. Okay. So what would be the answer for this? Pawan is saying C, Rakesh is saying C. Look at it. They are asking you bending moment at roller support. There are two things you need to think about. First thing is, if they ask bending moment at roller support, second thing, bending moment reaction offered by roller support. Okay, it is like that. So my dear, the answer you have given is not true for the statement. This is true for the statement B. If they would have asked what will be the support reaction given by the roller support. When we are talking about roller support, you are aware that roller support can give only one vertical reaction. But they are not giving any reaction in terms of moment or horizontal force. That's true. But my dear, it doesn't mean that we cannot apply the moment onto that. Like if you see this moment, you are going to find out bending moment at a section. To the left hand side, 100 Newton meter is applied. So bending moment at that section which is applied is 100 Newton meter. It is not going to be 0. 0 will be the reaction. But what they are asking, they are saying bending moment at the roller support. They are not saying bending moment reaction by the roller support. It is like, let us say in our class, there is a student, let us say I am taking the example of Pejal word. So this Pejal word student, let us say he can understand the Hindi but cannot speak Hindi. So he cannot speak Hindi but can understand the Hindi. So if I will be speaking in Hindi, he will get what I am saying. So the point is, this support cannot give you reaction in terms of moment. It do not know the language of moment while speaking, but it can understand the language of moment. Means if you will apply, that's fine, but its reaction will not come in that way. It will react only with the force only. Means even if I will be speaking to Pejal in Hindi, Pejal will answer in English only because he can understand Hindi but cannot reply in Hindi. He cannot speak Hindi. So this cannot give reaction in terms of moment. But if you will apply the moment, it will bear it by giving the support reaction in this way. So guys, please tell me, everybody got it or not? This is the load applied now. This is the load applied. When you find out shear force or bending moment in a beam, you are finding out in a section, method of section. What you say, the net moment at this roller support or at this point or at this section will be the algebraic sum of all the forces or moment either to the left or to the right hand side of the, yes or no? So if you will see the left hand side, you are having this 100. For right hand side, you need to find out the reaction if you want to check from right hand side. Then this into that distance will be once again the bending moment. So you can find out from left side or right side. So guys, this is the biggest confusion students are having. Now please tell me, everybody is getting it or not? Yes, Anubhav, this 100 Newton meter was given in the question. You can see na? Okay, I am telling you, if I will delete it, this is already made 100 Newton meter. Okay, is it clear? So answer will be A for this. Answer will not be C. Answer will be A for this. Wonderful. Anybody have any doubt? Please ask. This was a wonderful question and that's why I have taken, because I know where our students are doing the mistake. So guys, do like the session so that other student can also get benefit of that. Next question is this. This is easy question. I feel everybody can do that. A rod of variable cross section, area is changing. At one end is subjected to an axial load P as shown in the figure. If allowed normal stress in tension is 100 MPa. So material can bear only up to 100 MPa. Then the maximum allowable load will be. So you need to tell the value of load. Okay, just solve it. So this is bar 1. Okay, this is bar 2. You can write down the force in the member. Method of section. To the right hand side we have P load. To the right hand side we have P load. So we can say both member are having equal force. And you know, if we will be writing P, so with respect to first bar, we can write it sigma 1 A1. Okay, sigma 1 A1. So we can write the P as sigma 1 A1. Sigma 1 can have a maximum value of 100. So 100 into area 1 is 0.5. Okay, 1. So this is the maximum load which first member can bear. Similarly, maximum load which second member can bear is 100 into 0.5. So out of these two, the minimum will be your answer, because according to us, we need to find out that maximum value which this entire bar will be able to withstand. So you can see the first member can bear around 100 meganewton and this can bear 50 meganewton. So if you are going to apply more than 50 meganewton, then first bar is going to, sorry, second bar is going to fail because its limit is 50 meganewton and its limit is 100 meganewton. So you need to put value to be 50 meganewton so that both the bars will remain the same. So C will be the right answer. Very good, Arun. Wonderful, guys. So it is not Newton, it is meganewton because stress was given in MPa. Is it clear? Is it clear, everyone? Anubhav, Arun, Madale? Very good. Moving to the next question, guys. When a solid circular shaft is in pure torsion and deforms elastically, then the shear stress in the shaft is. Very good, Wahid. Very good, Wahid. Then shearing stress in the shaft is inversely proportional to shear modulus, varies linearly with the radial distance from the axis of the shaft, varies linearly with the length of the shaft, is inversely proportional to the diameter of the shaft. So just solve this question. This is a good one. Solve this question. This is a good one. Solve this question. This is a good one. Everyone. Very good. Well, B will be the right answer because you know whenever we are going to make the shear stress distribution, if you are applying the torque like this, then shear stress distribution are coming like this. Here shear stress will be maximum. Here also it will be maximum. And at center it is going to be 0. And this is the linear variation. So you can say tau by R is equals to G theta by L is equals to T by J. So you can write tau is equals to T into R by J. So tau is directly proportional to R. So B is going to be the right answer. Is it clear for everyone? Yes, please tell me, guys. Now I am properly audible. Everybody. Everybody. So guys, what about this question? This is the next question. Sorry for the inconvenience, guys. Actually, sometime network, as because of bad weather condition, is creating problem. Okay. Now everything is fine. Wonderful, guys. So solve this question. This is a very good question, guys. And this question says that at a point in the body, the normal stress is sigma and sigma y is sigma. E is the Young's modulus, mu is the Poisson ratio of the material, assuming the material to be linearly elastic isotropic. For plane stress condition, the ratio of sigma x and epsilon x is. So you can see they have this loading condition. They have given this loading condition. Sigma xx, sigma yy. But the point is both are equal. Both are equal. Try to solve it. Abhijit is saying A is the answer. What about others? This is a good question, guys. You need to find out sigma xx to epsilon xx. So I feel you can write here epsilon xx to be sigma xx upon E minus mu times sigma yy upon E. So my dear, both are sigma. You can write sigma xx and sigma yy are equal. So we can take it common. Sigma xx upon E will be common. It will be 1 minus mu. So I feel this is very easy to find out now. Okay. Now it is clear, guys. Please tell me that. Sorry, guys. Once again, actually, as I said, due to bad weather, electricity is also not there. That's why this thing is happening. Sorry for that, but don't lose your interest because I am telling you each and everything. So sigma xx by epsilon xx, that will be equals to what? That will be equals to E by 1 minus mu. So answer to this question is nothing but A. So A is the right answer. Wonderful guys. Rakesh, Anubhav, Pejal word, very good. Moving to this question, this is a very good question guys. Triangular cross section is given to us. There is a cantilever beam has cross section of an isosceles triangle and is loaded as shown in the figure. This is the loading given. Okay, this is the beam. Beam and the cross section of this is triangular. So I feel everybody is aware that for triangle the centroid will be coming h by 3 from here and 2h by 3 from here. And as per the given bending moment, top fiber will be in tension, bottom fiber will be in compression. And you need to find out the maximum tensile bending stress. Maximum tensile bending stress. You know bending stress is M Y by I and A. You need to find out maximum. When sigma B will be maximum, bending moment is constant. When Y will be maximum. All the values are given to you. You just need to find out the tension from the neutral fiber. Distance will be taken. Okay, just solve it guys. Thanks Arun. So just solve it. This is the bending moment given 3 meganewton meter. This is I value given 1 by 36 meter 4. Try to solve it. Anubhav is saying the answer to be C. Okay, what about others? Anubhav is saying the answer to be C. C means 36 MPa. What about others? Pejal word is saying C. What about Rakesh? Arun? Rakesh is saying C. Yes, Arun, waiting for your answer now. Yes, guys. So, it is 3 meganewton meter. So, you can say this is 3 into 10 to the power 6 if you are saying it is Newton meter. Then Y maximum distance is going to be h by 3. And if you see, they have mentioned it total 1 meter. So h by 3 is going to be 1 by 3 into 1 by 3. Here also the units are in meters. So no need to convert. Divided by INA is nothing but 1 by 36 meter ki power 4. So when you will solve this, 3 will get cancelled out. Answer will be C. 36 is going to be the right answer. Arun, 2 by 3, nahi, we will take 1 by 3 because tensile stresses will be coming on the top fiber. If they would have asked compressive stresses, then we will be keeping it to be 2 by 3. Okay, for compressive stresses 2 by 3, for tensile stresses 1 by 3. Very good. Wonderful, Madala. Okay, moving to the next question, guys. This is a long cylinder column is pin supported. At the end, the compressed by an axial load as shown in the figure. They have given you I11 and I22 and Young's modulus is 100 GPa. Then the critical load for buckling. Buckling means Euler's theory. So I feel you are aware that you know the formula for buckling. Both hand hinge. It is pi square EI minimum upon LE ka square. You know LE is L, which is equals to pi meter. So just put the value, get the answer. Sachin, good morning dear. Sachin, now don't miss the opportunity. I know you would have filled the form of ISRO. Don't miss the classes. If you will be attending these classes, who knows 70-80% question will come as same only. Many times it happens. You won't believe, once there was vacancy for YJAC Steel. We have taken the complete series and more than 30 students from our YouTube students got selected. More than 30. And they said, sir, questions were almost same what we have done in the classes. Because when we are coming, we are not coming with any question like that. We are doing the research, what kind of questions are being framed. Similar question we are making, because when they are repeating every year, it means the similar question will be coming. Okay? Fine. Anubhav has said 100 kilonewton. What about others? Very good, Anubhav. I feel you are going and doing the preparations on track. Just continue that. Okay, Pejal, it is 100 or 1000. Sachin, every Monday, Wednesday, Friday, Saturday, 11 a.m. where we are going for Monday, Wednesday, Friday subject wise, Saturday one previous year's paper, and on Sunday I will be planning soon the aptitude classes. Okay, so till now there are 3 plus 1 going on. So answer is 100 kilonewton. So when you will put the value, you know, pi square, okay, into what is E is 100 GPa, 100 into 10 to the power 3. Then my dear, I minimum, you will be taking 100 or 200, 100. So you will say it 100. And when it is centimeter to the power 4, so 10 to the power minus 2 into 4 minus 8 divided by pi ka square. So you will get 100 kilonewton as the answer. Okay. This is 100 into 10 power plus 3. Okay. That is MPa. So I will write 10 to the power 9. So that this becomes Newton per meter square. Now you will get the answer as 100 kilonewton. Moving to the next question, guys. Yes, Pejal, Anubhav, Sachin, Arun. This is easy question. The linear relation between the stress and strain of a material is valid up to fracture elastic ultimate proportion. Rakesh is saying B elastic. What about others? Pejal is saying B elastic. What about others? Yes, Lakshmi, are you there or not? Arun is saying D. What about others? Wonderful, guys. Sachin is saying D. Okay, what about others? The answer will be D, my dear. So many students have confusion there. I am clarifying your confusion. When someone asks you the Hooke's law, how you will define? You will be saying, according to Hooke's law, stress is directly proportional to strain up to elastic limit, but later on it was corrected to proportional limit. Because elastic limit, proportional limit and yield point, they are very close to each other. It was a difficult phenomena to differentiate them. That is why, my dear, the answer will be proportional limit only. But yes, for the first time, Hooke's have said it elastic limit, but it was corrected to proportional limit. So now what will be the answer? Proportional limit. Okay. But yes, if someone asks you, you can tell that later on it was corrected to proportional limit. Answer will be D only. Next question. Which of the following can be measure of ductility of a material? Area under engineering stress strain diagram, percentage reduction in the area in tension test, yield stress or ultimate stress. What can be the measure of ductility? Anubhav, Pejal, Arun, Lakshmi, Abhijit. Rakesh is saying B. Okay, what about others? So out of all of you students who have not joined my Telegram channel, do join it. You will get the PDF of this session on that only. Madala, very good. Sachin, B. Okay. So you have given your answers. I said very good for your answers. Okay. I didn't say what is correct. The correct is going to be B. So my dear, when we are talking about engineering stress strain diagram, you are making the curve like this. First of all, when we are talking about this area gives us toughness, not ductility. First of all. This area gives us toughness, not ductility, first of all. And my dear, when we are talking about the yield strength is going to be the value related to y-axis. Ultimate strength is value related to y-axis. This will only give you the strength of material, will not give you ductility. Ductility is defined as what? First of all, generally student says it is the ability of a rod converted into wire. It is not correct. When we say definition, if I say what is anger, you will say, sir, angry person can kill other. This is application of anger. This is not definition. Ductility means what? You are saying rod is converting into wire. That is application of ductility. When the rod will be converted into wire? Two cases. One thing, it must be capable of withstanding tensile forces. Because when I will apply tension onto it, if it cannot withstand tension, it will fracture. Then we cannot make the wire out of it. So first definition of ductility, that it must be able of withstanding the tension. And once I will convert it into the wire, it must remain wire. Because if it will be elastic, it will, after removal of load, will regain its shape and size. Then there is no point of making wire. So second thing is, it must have the deformation to be permanent or plastic. So ductility means plasticity. And any material is said to be ductile if it's post-elastic strain. What is post-elastic strain? Plastic strain. So if it post-elastic strain is going to be more than 5%. So my dear, that you can get only with the reduction of area, because reduction of area will give you increase in that permanent length. So that is why the answer is going to be B for this. But if someone asks you that ductility will come with which property, then ductility always comes with the toughness. Because if you will be having more toughness, then my dear, it is possible with more horizontal distance. Out of this, one part is elastic, other part is plastic. So toughness and ductility go on together. But for this question, right answer will be B, because it is more exact. But otherwise, ductility, toughness go together, hardness, brittleness go together. So always remember this. Okay, I feel this is the extra knowledge for you, that always ductility plus toughness go together and hardness plus brittleness go together. Moving further. Next question, guys, is very easy. This type of question 5 times asked in ISRO. 5 times. At the point of contra-flexure of beam, what you are expecting? At the point of contra-flexure of beam, what you are expecting? Are you expecting shear force to be 0? Are you expecting sign of curvature in the deflection curve changes? Are you expecting the bending moment reaches maximum value, or maximum deflection will happen? Arun is saying A. Okay, point of contra-flexure. What about others? थोड़ा सोच लो अरुण, जल्दबाजी में आंसर नहीं करना है. Rakesh is saying B. Okay. Wonderful. What about others? Okay, what about others? So guys, I feel everybody is aware of that when we are talking about point of contra-flexure. Then point of contra-flexure is the point where bending moment changes its sign. Bending moment changes its sign and becoming equals to 0. This is the point of contra-flexure. Shear force 0 is going to be the point of maximum bending moment. That cannot be our answer. Okay? And this are same. When bending moment reaches maximum value, then shear force is 0. A and C are same. When we are talking about the deflection to be maximum, for that we will be having dy by dx, that is slope to be 0. That is going to be slope to be 0. So my dear, sign of curvature in the deflection changes. Yes, it is going to be the answer, because when we are talking about the theta is coming out to be by integration of bending moment, you know that, and deflection is coming out by double integration of bending moment. So answer is going to be B, because you are aware of 1 by R is equals to M upon EI. So when the bending moment will become 0, R is going to be infinity. Okay, very good guys, बहुत ही बढ़िया. हाँ. Yes, next question. A material has a Poisson ratio of 0.5. If a body is made up of this material and subjected to external forces, then the final volume of the body, thrice that of the initial volume, twice that of the initial volume, 0 and equal to the initial volume. Very easy question for all of you. Very easy question for all of you. This is how the question can be twisted. I feel everybody aware the volumetric strain expression. It is 1 minus 2 mu upon E. Sigma xx plus sigma yy plus sigma zz. I feel everybody is aware of this. What will be the answer, guys? Wonderful, wonderful. Okay, some are saying C, some are saying D. So my dear, if they would have asked you volumetric strain, that will be 0. It means change of volume is 0. It means initial volume is final volume. So answer is D for this. So don't have any confusion in this. D will be the answer. Okay. Volumetric strain is 0 and volume is going to be constant. Wonderful guys. Really happy with your response. Moving to next question, guys. Yes. This one, all this one. When a uniaxial tensile load is applied to a rod fixed at one end, both engineering stress and true stress in the rod depend on the type of material. Engineering stress is the rod depend on the type of material, but true stress in the rod does not depend on type of material. True stress in the rod depend on the type of material, but engineering stress do not depend. Both engineering stress and true stress does not depend on the material. What is the answer to this question? Very good question. This is a wonderful question. Yes. Anybody, please answer it. Please answer it. Pajal word is saying the answer to be C. Okay, what about others? What about others? Only Pajal have given the answer. Anubhav is saying A. Here I can expect the wrong answers from your side, because that kind of mistakes you are doing. I understand that. That's why I have taken this question. Rakesh is saying C. What about Arun? What about Lakshmi? Madala saying C. To be very correct, none of this is correct till now. A and C both are wrong. Lakshmi have given the right answer. B is correct. B is correct. Okay. Sachin, A. Okay. I am telling you what is going to be the answer. I feel you are aware that engineering stress is defined as force but a area. Okay. So whenever I tell you that, just tell me. If I tell you that this is a material or component on which load P is applied, A is the area. And if I ask you stress, have you ever asked about the material? When I ask you what will be the stress induced, you will never be asking, sir, which material it is. Have you ever asked, sir, E value is not given to us? No. You will directly tell, sir, P by A. But whenever we are talking about the strain here, you will say stress by E. Yes or no? So for strain, we will require the E. Material will be required here. Okay. But my dear, if we talk about the true stress is given as engineering stress into 1 plus engineering strain. So my dear, this will be depending on material. So answer for this is B only. Okay. So my dear, even you must have seen when we are talking about the bending as well. If I say it is a square section, then you know bending stress is defined as M upon Z, and Z is going to be A cube by 6. Whatever be the material, bending stress will remain the same. Okay, but the strength is different. Okay, stress is going to be same, strength is going to be different. Okay. Yes. So my dear, whenever we are talking about the stress, engineering stress is independent of material. True stress depends on material. Aarti, answer is B for this. Answer is not C. Answer is B for this. Engineering stress in rod depend on the type of material of the rod. Okay, I feel I have given wrong. C is correct. True stress is depending on the type of material. Sorry. C is the right answer. Sorry. I have read it opposite. Okay, so Lakshmi, you are not correct. C option is correct. Sorry for that. Okay, C is correct. So as I said, engineering stress is independent of material, but true stress will depend on material. Got it? My explanation is same only the option I have read opposite. I read B as C and C as B. Everybody got it? So C is correct. Those who have given C is correct. Next question. This is from strain energy. Okay, then some of you have given the right answer. Okay. PL cube upon 3I is the deflection under load P of a cantilever beam. And the strain energies. Okay, no issues dear. So as I said, I explained it that way only, but option I have read it opposite. Sometimes it happens as electricity is not there, so without AC I am taking the class with the huge lights. Okay, so it happens. AC is required when lights are running on because it creates a lot of heat. Abhijit is saying the answer to be B for this. I feel it is going to be correct only. Yes, you know that del U by del P is given as the deflection. Or you can also write U is equals to 1 by 2 into P into delta. So you need to find out the strain energy. Half into P into PL cube upon 3 EI. Answer will be B for this. Very good, guys. Next question. This is ISRO 7 type repeated question, 7 times. That's why I have added this question, because it is repeated for 7 times in ISRO. So from 2004 to 2020, whatever the exam happens, 15-16 paper, out of that 6 to 7 times it is repeated one. Yes. So a short column, external diameter D, internal diameter small d, carries an external load W, the greatest eccentricity which the load can have without producing tension on the cross section of the column. This is from the concept of core, kern or kernel. If you remember, we have solved this question in the PYQ section. Yes, C or D. C or D. Everybody would be knowing answer will be from C or D. This is the column. And let us say the load is acting somewhere here. So you know that because of this load, if you see the effect on the centroid, you will apply one load downward, other load upward. So because of this and this, you will be creating a couple like this. So you know, whenever we will make the state of stresses, distribution of stresses, the effect of compressive load will be like this. And the effect of bending couple, it is going to be compression here, tension here. So you want no tension. It means this tension and this compression should be equal, because only this fiber can have tension. If this fiber will not have tension, the entire column will not have tension, because this have the excessive tension from moment. So you can write minus P by A plus M by Z is equals to 0. That will give you the value of eccentricity. Minus P, area is pi by 4 d square minus d square, plus P into E. E is the eccentricity of the load, divided by, it is ZNA. ZNA when we are talking about is INA by Y maximum. Y maximum is capital D by 2. And INA is pi by 64. D4 minus D4. That you need to equate it with 0. Yes, Arun is saying C, Sachin is saying C. So my dear, you know that PP will get cancel out, and minus plus when you will be playing with pi cancel out. 4 will give you 16 here, 16 will give you 8 here. So you will be getting eccentricity to be equals to d square plus small d square upon 8d. Why you will get this? Because my dear, this d square minus d square will give here d square plus d square. I feel now it is very easy. A square plus b square, a square minus b square. C is going to be the right answer. Everybody understood this? For this question, even if you are remembering the answer, there is no problem. Because when it can repeat for 7 times, it can repeat for 8th time as well. Okay, very good, Pejal, Arun, Madala, Lakshmi, are you solving it or not? Moving further, guys. If the radius of wire stretched by a load is doubled, then the Young's modulus will. If radius is doubled, what about Young's modulus? Okay, Lakshmi. Then try to answer so that I get to know you are answering. Wonderful, guys. Solve this question. Solve this question, guys. I feel we have solved around many questions we have solved. This is question number 16. 8 more questions after this. 8 more questions after this. If radius is doubled, what about Young's modulus? Okay. Okay. So dear, Young's modulus property of material. It is independent of size. So when you will do the radius double, triple, any number of times, it is going to be unaffected. Moving to question number 17. Longitudinal stress in a thin cylinder is subjected to internal pressure is. Longitudinal stress is how many times of circumferential stress subjected to internal pressure is. Very easy question. This is a question which asked in civil engineering gate as well for 1 mark. In mechanical, they have asked about the ratio of strains. Abhijit is saying A, half of the Hooke stress. Everybody agrees? PR by T, PR by 2T. A will be the right answer. Very good, Lakshmi. Wonderful. Next question is very easy. Cantilever beam subjected to bending moment. This case have been repeated in GATE, ISRO, DRDO many times, many times. If you remember yesterday, we have seen this in the GATE PYQs as well from mechanical. Vikrant is saying A, Pejal is saying A, Abhijit is saying A. So answer is A, ml square upon 2EI is correct. Very good, Sachin. ml square upon 2EI is correct. Wonderful, wonderful, wonderful. Moving to the next question. So we have kept some difficult question plus some easy question. If Poisson ratio for a material is 0.5, then the elastic modulus of the material is. Please tell me, you learned something new today or not? Every day the target should be you must learn something new and prepare what you know already with revisions as well. Ha, Anubhav, your comments are visible. Great, great, great. Very good, Jitin. Wonderful. So answer coming is 3 times the shear modulus. You know E is 2G, 1 plus mu. When Poisson ratio is 0.5, E will become 3G. A is correct. Okay, A is correct. Wonderful. So when you are going to have mu is equals to 0.5, K becomes infinity. K becomes infinity. In I section, shear load is resisted mainly. Shear stress distribution is coming like this. So can you tell me that if we are making the I section, this is I section. So can you tell me if this is flange, this is web, this is flange. Flange is kept wider for bending stress, not for shear stress. Because when you see the bending stress distribution, it is coming like this. So keeping bending stress into mind, flange are kept wide. So answer will be web only. For shear web, for bending stress, these flanges. Very good, guys. Moving to next question. Shear forces, rate of change of loading, sum of bending moment, rate of change of bending moment, or none of the above. What do you feel by this? Shear forces. Okay, Arun is saying C. Rate of change of bending moment. Anubhav is saying C. Vikrant, Sachin, Lakshmi, Madala. Sachin is saying C. Everybody know that differentiation of shear force is given as load intensity and differentiation of bending moment given as shear force. C is correct. So initially we have seen some difficult question numerically, some conceptual question which are going to be somehow tricky. Now we are having some easy questions as well, because all type of questions have been seen in the ISRO paper. Maximum shear stress in Mohr circle is equals to. This question 2 times repeated in ISRO. Not directly, indirectly. Very easy question it is. Maximum shear stress in Mohr circle is equals to. I feel everybody is knowing that radius of Mohr circle is sigma 1 minus sigma 2 by 2. Because when we plot a Mohr circle, this is sigma 1, this is sigma 2. So in that case, you already know in plane tau max shear stress is also sigma 1 minus sigma 2 by 2. The answer will be radius of circle. There are some questions asked on this relation as well. So I am telling you as a bonus that always the algebraic sum of two mutually perpendicular normal stresses means the normal stress is on two mutually perpendicular planes. Their summation is always going to be equal. Many questions are being framed nowadays on this formula. Even they are doing it in terms of strain as well. Like xx plus yy. 1 plus 2. Theta plus 90. Okay, moving further guys. If material expands freely due to heating, this type of question have been asked in GATE as well, in 1 mark. Engineering Services, ISRO, DRDO, BARC. There is no exam where this question have not been there. When we are having the free expansion means, you know, strain will be coming, stress will not be coming. Why? Because stress always comes when strain is restricted. Until you have restriction for the strain, stress will not come. Stress always comes when strain is restricted partially or completely. Otherwise, stress will not come. So answer is going to be C for this. Okay, this is a good question. When a column is fixed at both the ends. This is a famous question for engineering services and ISRO. Every year one question on one boundary condition comes. Yes. I feel you know the general formula for Euler's buckling load. Pi square EI minimum upon LE square. So you know for this both hand fix. L is L by 2. So it is 4 pi square EI minimum upon L square. Everybody, okay. Once again video stuck. Yes, everybody got it? Okay, I am repeating the answer because I feel video got stuck. Now is it clear? So you know the buckling load formula is pi square EI minimum upon LE square. Don't worry, I will fix this problem. In the next class, this problem will not happen. LE ka square. So when we are having pi square EI minimum upon LE square, you know LE is going to be L by 2 for this case. So answer will be 4 pi square EI upon L square. D is going to be the right answer for this. Fine. Moving to the next question, guys. I feel now we have completed 23 questions. This is the last one. For a body subjected to direct stress, the direct strain epsilon x in x direction is. This is easy question. Poisson ratio is shown by gamma. What will be the right answer? Rakesh and Anubhav said B. You know epsilon xx, sigma xx by E minus mu times sigma yy by E. But jaldi mein students are going to tick A. They do not see this is plus, this is minus. So that's why keep. Okay. Yes, Kamran. Very good. So guys, although we have completed 24 questions, but these two questions are bonus question for you guys. These two questions are bonus questions. A circular shaft subjected to torsion undergoes a twist of 1 degree. So theta is 1 into pi by 180. Length is 120 centimeter. Maximum shear stress is this. If the modulus is this, then the radius of the shaft is. You know tau by r. Maximum is given, then r maximum. G theta by L. So to find out r max, it is tau max L upon G theta. Put the value, get the answer. Very good question it is. Yes. So Pejal, as I already said, we have matched the ISRO level. Because in ISRO, you are going to solve around 95 questions in 120 minutes. So you cannot have the level of gate here. But still we have kept some questions of very good level. Because in ISRO also some questions are coming like that. That's why cutoff is always remaining 50 to 55%, at the max 60%. So in that way, as per the exam pattern, we are going with. Okay. What would be the answer for this question? Tell me that. The radius. Tau max is, don't worry, but in upcoming session, we will also have some very good level question. Because in every session, my target will be to teach you something which you will not be aware of before. Like today, you got some explanation of true stress, engineering stress. You got explanation of maximum shear stress theory. You got explanation where everyone have given the wrong answer in 1 to 2 questions. So those kind of new things will help you. Okay. So what would be the answer? This is 1000 kg per centimeter square. Length is given as 120 centimeters. Divided by G. G is 0.8 into 10 to the power 6. And then we are going to have theta as 1 into pi by 180. Solve it. 27 by pi is correct. Very good, yaar. You guys are awesome. Last question. A hollow shaft of same cross-section area as solid shaft transmits same torque, less torque, more torque, or unpredictable. They have said that the area, a hollow shaft of same cross-section area. So I feel you know that torque is directly proportional to ZP. So if you want to find out the ratio TS by TH, you can write ZPS upon ZPH. Their areas are given equal. So for this pi by 16 d cube, pi by 16 d naught cube 1 minus k4. Here di by d naught is k. So you need to check it and tell which one is correct out of this. Okay. So when you will have this, pi by 16 will get cancelled out. Area is given equal. Pi by 4 d square is pi by 4 d naught square 1 minus k square. So pi by 4, pi by 4. Areas are given equal. So d square by d naught square 1 minus k square. So you can write this cancel out. This will be d square by d naught square into d by d naught into 1 by 1 minus k ki power 4. So it is 1 minus k ki power square into 1 minus k ki power square. 1 minus k square, 1 plus k square. So Ts by Th. Now you can decide for equal area what is going to be the case. Okay, there are two cases we have studied. For same outer diameter, solid are good. For same weight, hollow are good. There they have mentioned the hollow shaft, same cross section. They have nothing said about any other thing. Okay, so you can find out, I feel, what will be the answer. Okay. Note D, Arun, because you know that K is always going to be less than 1. So you can very easily find out. K is less than 1. So 1 minus K ka square, 1 plus K ka square. I feel this term is always going to be more than 1. This term is always going to be less than 1. So you can directly say Ts less than Th. When weight is same, if weight is same, then also hollow are better. Is it clear? C will be the right answer. Everybody got it? Please tell me that. So when weight is same, when when cross section are same, both the cases will give you hollow to be better. So guys, this was the today's session. Please rate this session. Tell me you like this session or not. If you want anything extra to be added, you can mention in the comment. We will definitely work with that as well. But as I said, I tried to give you a combination of some very good questions, some average question, some easy questions, and some PYQs. In this 24, 4 PYQs were also there. Those PYQs were asked 6 to 7 times. Okay, great guys. So now, as I said, this series will go on Monday, Wednesday, Friday, 3 days. And Saturday will be the previous year paper. Okay. And if you want some specific previous year paper, you can also mention that. Otherwise, we are going with sequence from 2020 to 2005. Already we reached till 2015. Okay. Fine. So goodbye guys for your wonderful response. We will meet again soon and just continue your preparation in that way. Goodbye guys. Join my Telegram channel to get the PDF of this session. Mechanical by Dheeraj Sardana. Okay. Goodbye.